student, for the Cornell students, this board. Okay. Next one, this is called a state equation. This is called state equation. EQ means equation. Second one, y of t equal to c into x of t plus d into u of t. This is called, because y of t output, this is called output equation. Combinedly, these two combinedly, let me use a different color. These two combinedly, we can call this one as a, one second, we'll call this one as a state model. We can call this one as a state model of a system, state model. So this all are, first if we check the first one, anyway, this y of t is output. Y of t is output. This u of t is input. If you want transfer functions, we have to give the relation between these two. Already I explained in the previous class. Now you check the first state equation. State equation is nothing but differential equation. I'm writing this state equation here. X dot is nothing but first derivative, dx of t by dt. X depends on t, that's why x of t. X dot of t means first derivative, dx of t by dt. That equal to a into x of t plus b into u of t. It is a differential equation. It is a differential equation. I want x of t. I want x of t. Don't tell if you want x of t, you can keep this one to the left side, then send the remainder to the right side. It is meaningless. Why? Because there is one more x of t. This x of t is the first derivative, dx by dt. It is also x of t. It is also x of t. If we solve this differential equations, we will get the solution. That solution is called x of t. Are you getting my point? My question is, what is the solution of state equation? This is nothing but, x of t is nothing but solution of a state equation. Solution of a state equation. Solution of a state equation. Why? The state equation is nothing but a differential, first order differential equation. Then how to obtain the solutions for a differential equation? We are having different cases. If it is a first order variable separable method, homogeneous method is there, linear differential equation method is there, Bernoulli's equation is there, exact differential equation. Different methods are is there. I'm not going to use. That is a max subject. Anyway, x of t in exam, in a competitive exam or anyway in any exam, state board, central board, they will ask what is the solution of a state equation. Please listen. X of t is nothing but solution of a state equation. Solutions of a state equations. Next, I wanted to discuss one more point here. Next one is a homogeneous equation. This also is studied in maths. There are different definitions for homogeneous equations. If it is a differential equations, then there are also homogeneous equation. If it is a partial differential equation, there are also homogeneous equations. If it is a linear algebra, there are also homogeneous equations. If it is a control system, homogeneous. That depends upon the subject. Okay, now in this case, what is a homogeneous equation? So what is a homogeneous equation means? If input within bracket I'm writing u of t is input in this case. If input is zero, then that equation is called homogeneous equation. If input is zero, then x dot of t equal to a into x of t. Why? Because this u of t is zero. If input is zero, then x dot of t equal to a into x of t. This is called a homogeneous equation. Homogeneous or state equations also, but different meaning is there. Homogeneous equations. If input is not zero, then it is called non-homogeneous equations. Because it is a MCQ test, we have to get the answer within 1 minute. That's why I will give the questions from homogeneous equations. That's why I will give the question from homogeneous equations. Let me derive how we are going to get this one, because it is a differential equations. It is a differential equation, not x of t. Solution means I have to find x of t. In exam, they will ask find the solutions of the state equations. If they're asking find the solutions of state equations, we have to check whether the input is 0 or not. Because it is MCQ, you have to get within 1 minute. I'm giving the question from homogeneous. Anyway, I will solve the non-homogeneous questions also. If input is 0, then solutions of that, then it is called a homogeneous equation. Let me write the solutions, how to obtain the solutions. This is dx of t by dt equal to a into x of t. This is the differential equation. First order differential equations, we have so many methods to obtain the solutions of a first order differential equations. Anyway, without confusing the students, we know general solution. What is the advantage of using Laplace means within, even though you are using different methods to obtain the solutions of first order, assume that will take in 1 minute time. If you use Laplace, it will take 30 seconds to get the answer. That is advantage of using Laplace, otherwise applying Laplace for a differential equations. That may be first order, second order, or higher order. Anyway, I am applying Laplace on both sides. Apply Laplace on both sides because it is a first order. Because it is a first order, its Laplace is already explained the signal system subject also. S into y of s. If it is a first order, we will get s. If it is a d square means s square. D cube means s cube, I told. But when I am applying Laplace, because I told state space analysis is going to consider all the initial conditions. What is the drawback in Laplace transform is we are losing the initial conditions, but in state space we are not going to lose. That's if you apply Laplace transform for first order, this is not s, because it is not y, it is in terms of x. Yes or no? S into x of s, because it is x of t, minus, check the difference between small x, capital X. Why I'm using, I'll tell later. That equal to A is the matrix, x of t is the time domain, so x of s. So why I'm using this x, small x of t, this capital X of t means the small x of t is giving the information about in terms of time. Check it is a Laplace means s domain. Laplace means s domain. Small x of 0 means this is the data with respect to time. At t equal to 0, initial conditions at t equal to 0, what is small x of 0? In the exam itself, they will give at t equal to 0. That is it. That's why I'm using the difference between capital X, small x. If you refer to some local author something, they will use the same symbol. Anyway, initial conditions are always with respect to time. The remaining it is Laplace, S operator, Laplace operator. Anyway, it is a x of s, it is a x of s. Take to the left side, you will get s minus a into x of s. Don't feel because ma'am is making the cooking, that's I'm getting some. Okay. Then you send this x of 0 to the right side. Check it out. A is the matrix. If you take this this way, is a into x of s to the left side. X of s common, take it as a common factor, s minus a. But it is not x minus a. S is the operator, a is the matrix. So it is not possible to subtract a one value from matrix. That's I'm using I matrix. So I order and A order will be same. If A is n by n, I also n by 1. A is 3 by 3, I also 3 by 3. Yes, I want x of t. I want solution means x of t I want. Yes, from this one, let me use the next slide. Yes, I minus a into x of s equal to x of 0. So keep, otherwise pre-multiply, post-multiply, you studied in C language. So I'm multiplying, pre-multiplication, pre-multiply the both equations. I mean, pre-multiply on both sides with si minus a whole inverse. Then x of s equal to si minus a whole inverse. Otherwise, send this one to the left side and take to the numerator, that's all. Don't use a different language, a difficult language to understand. Yes, check it out. This is x of s. This is, if you apply inverse Laplace, inverse Laplace, then x of s will become as a x of t. Apply inverse Laplace on both sides. This is in terms of s now. So if you apply inverse Laplace, otherwise let me write this one as a L inverse, numerator is x of 0, time domain, that is a value, Si minus A. So x of 0 is the constant. X of 0 is a constant. I'm taking outside. Then L inverse of 1 by Si minus A is nothing but e power At. Then outside is x of 0. Very, very important. Finally, I got the solution of state equation is e power At into x of 0. I want to make some highlights here. Please bear with me. I want to give some formulas which are useful in state space analysis. Some Laplace L inverse formulas. First, Laplace of e power At is 1 by s minus A. If it is a minus A, it is a plus A. Check it out. S minus A. If it is a minus A, e power plus A. Laplace of e power minus At. It is, because it is a minus A, it is s plus A. S plus A. Next, Laplace, otherwise let me use L inverse, same thing, L inverse of s plus A. That means send this Laplace to the left side, it becomes L inverse. L inverse of 1 by s plus A is nothing but e power minus. Both are opposite symbol. In the same way, L inverse of 1 by s minus A, opposite symbol, plus At. In the same way, Laplace of 1 by s, L inverse of 1 by s is 1. L inverse of 1 by, instead of writing 1, they will use control system u of t equal to 1. Okay, and they will use L inverse 1 by s square, yes, t. In the control system, extra you have to put a t into u of t. Last one, not last but one, L inverse of s minus A whole square. Listen, if there is no square, then it is e power At. If there is no square, it is e power At. If it is a square, take t. These are the formulas we come across in control system state space analysis. Let me give two more. After that, we'll go to the normal topic. These are the I require to solve the problems in state space. Next one, L inverse of 1 by s square plus A square. This is nothing but sin At. Use different color. Next one, L inverse s divided by s square plus A square. Then this one equal to cos At. Yes, these are the formulas are required to solve the problems in state space analysis. Okay, you come to this one. This is called solution of a state equation. This is called solution of a state equation. Very, very important. When it is possible, in this case, if this is a solution, if u of t equal to 0, that is input is 0. Other name, let me write other names of x of t in this case. If input equal to 0, then x of t is called, first one is solution of a state equation. Solution of a state equation. Second name, because input is 0, we are getting some response, we can call this one as a zero input response. Other name. Third one, they will ask, obtain the solutions of a homogeneous equations. Homogeneous solutions of a SOLN, solutions of a homogeneous equation.